One application of the law of cosines is with navigation, heading, and bearing. So in navigation, a direction is called a bearing, and that bearing is the angle measurement from due north or due south. For example, in this first one, we have the bearing south 45 degrees east, because the direction we're heading has a 45-degree angle from the south direction to the angle we're headed. That's 45 degrees, and it's heading easterly. On the second one, we're going north 45 degrees east because the angle is to the north 45, from the northmost axis to our path. We're 45 degrees and we're heading east. Similarly, in this third, we have our coordinate axis, and we're close to the southern part of our axis, and we form an angle of 45 degrees, and we're headed west. And in this last one, we are 45 degrees from the north axis, and we're headed in the west direction, so we're north 45 degrees west. So let's try an example. Let's say a boat starts traveling north 30 degrees east. A boat starts traveling north 30 degrees east at 20 miles per hour. So here's our coordinate system. It's heading north 30 degrees east. So that means that this angle is 30 degrees. And after half an hour, so we're traveling, and after half an hour, the boat then heads north 20 degrees east for half an hour. So we draw another coordinate plane, and we head north 20 degrees east for half an hour. So this angle is 20 degrees. After an hour and a half, what is the distance between where the boat started and where the boat stopped? So what is that distance? So if we draw ourselves out as a larger triangle, we can see more clearly. We know that we traveled at 20 miles per hour for an hour. So this is 20 distance equals rate times time. So 20 miles per hour for 1 hour, that's 20 miles. Over here, we're going 20 miles per hour for half an hour. So 20 times 0.5 is 10 miles. We're looking for this distance. What we need to know is one of these angles. Well, we know that we went from going 30 degrees to going 20 degrees east. So to find this angle, we take 180 degrees minus the 10 degrees that we shifted. So that gives us 170 degrees, is this angle here. So now we can use law of cosines. This side c squared equals 20 squared plus 10 squared minus 2 times 20 times 10 times cosine of 170. So 20 squared plus 10 squared minus 2 times 10 times 20 times cosine of 170. And that is 513.92. C squared equals 513.92. We need to take the square root of both sides. And we get 22.67. So C is 22.67 miles from where we started. So this distance is 22.67 miles. Now let's have you try to find the bearing from the starting point. So the boat starts traveling at north 30 degrees east at 20 miles per hour, and after half an hour the boat then heads north 20 degrees east for half an hour. After an hour and a half, what's the bearing from the starting point to the boat's final point? So pause the video, and when you're ready, come back and see if you got the right answer. So what we already know from the last problem is that this is 10 degrees. We know that this is 20 miles. This is 10 miles. So if you want to know where this 10 came from, watch the previous video on using navigation and bearings. We're looking for this angle here. So we found out that this side was 22.67 miles. So using our law of cosines, if we call this angle A, we have A squared equals B squared plus C squared minus 2BC cosine of A. So 10 squared equals 20 squared plus 22.67 squared minus 2 times 20 times 22.67 times cosine of A. So 10 squared minus 20 squared minus 22.67 squared is negative 813.93 equals 2 times 20 times 22.67, negative 2 times 20 times 22.93, negative 917.2 cosine of A. We divide both sides by dividing, we get 0.887 equals cosine of A. So inverse cosine of 0.887 equals A. And that gives us 27.54 is A. So 27.54 is this angle right here. But we want to know the bearing. So to determine the bearing, we know that this whole angle here, this whole angle is 30 degrees. So 30 minus 27.54 gives us 2.46, and that is north 2.46 degrees east is our bearing.